doing conditional probability, there's typically more than one possibility of something that could happen. And you just set up the diagram because not everything has equal probability of happening. So if you look at this example 5, it's telling you that a school system compiled the following information from a survey and then they sent it to people who were juniors 10 years earlier. So they're actually going back and asking their graduates, or some of them did not graduate, but just asking people that had attended their high school and asking them some different things about whether or not they graduated and how satisfied they are with their jobs. So if you are looking at this, it gives you some information. The very first thing it says, 85% of the students graduated from high school. So if you are making a tree diagram, if I want to talk about the responses that it could be. So the first thing we know is that some people graduated from high school. All right, so some of the people graduated. What would be the other response?
Did not graduate.
Did not graduate. So you have two options here.
So you always put them top and bottom of each other?
I would recommend it. So this person that's taking the survey, the first thing they're asking them is whether or not they graduated. So they either graduate or they did not graduate. Now, we call these a tree diagram because it kind of branches out. So each one of these lines is a branch. So some of the people are on the graduated branch, some people are on the did not graduate branch. Now it tells us here what's the percentage of people that graduated? 85% graduated. What is that as a decimal? 0.85. We never calculate probabilities with percents. We always do decimals. So I always write the probabilities along the branch. All right, so if 85% of these people graduated, what percent did not? What'd you say, Luke? All right, where'd you get 15 from? 100 minus 85. So if 85% of them graduated, 15% of them did not. What do you guys think about setting up that first part?
That's pretty easy.
That's pretty easy. All right, now it's going to give us information about these branches. Of the students who graduated from high school, 90% of them are happy with their jobs. So this second bullet point's only giving you information about the people that graduated from high school, so just ignore this for a second. If you graduated from high school, it says 90% of them are happy with their jobs. So some of them are happy and some of them are not happy. All right, and just like we did with the percentages on the graduation part, now we can do the percentages on these branches with the happy.
0.9.
0.9 would be 90%. So what percent is not happy? 0.1. If 90% are happy, 10% are not happy. And so we leave it like that.
It's pretty smooth.
All right, so now the third bullet point says of the students who did not graduate. So now we're ready to break down the second branch. We have people again that are happy, and what's the percentage of people that are happy in this next one?
0.6.
0.6. So then what percentage is not happy? 0.4. So we built a tree. So whenever you split the branches, whatever you're splitting, the two percentages here add up to 100. When we split up here, those two percentages add up to 100. When we split up here, those add up to 100. So now that we have our tree set up, we can calculate probabilities. So on this one, it says, what is a probability? So first of all, we're going to put a capital P for probability. It says, what's the probability that the person from the junior class 10 years ago graduated? That's the first thing we want to know.
85%.
And happy. Okay, so think about this when we were doing probability of multiple events. When we saw the word and, did we add or did we multiply? Oh, I don't think so. We multiplied. All right, so anytime you see the word and, you are going to multiply. What word is associated with adding?
Subtract.
Nope. Like, when you're finding probabilities, if you have multiple things going on,
More than?
Some.
no,
Because isn't division of?
yes, but I'm thinking like if I say the probability of this and this happening, we multiply. If I say what's the probability that you are happy or graduated, or is when you add, and is when you multiply. So when we see this, all right, so the first part, if we are doing graduated and happy, we are only looking at this top branch. We have nothing to do with the did not graduate. They have to be graduated and happy. So what's the probability of graduated?
85%.
0.85. Now what's the probability of the graduated but also happy?
0.9.
So graduated and happy. So we are actually going to multiply 0.85 times 0.9. So we got that. So we've got 0.85 times 0.9, 0.765. And there's absolutely no reason to convert that to a fraction. Just leave it as a decimal. So we just follow the branch. Graduated was 0.85, then that branch followed to 90% happy. So we multiply those together.
Dude, I just got the best hits of my life.
Nope.
I didn't answer it.
All right, now, hey guys, we've got one more here. All right, so it says, what's the probability? So probability notation, anytime we see the word probability, we got to write a capital P. Now in this one, we want to find the probability that the student from the junior class did not graduate. And I'm just writing it like this to save space. Did not graduate and is happy. All right, so let's follow the tree.
That's gonna be real slow.
Well, what's the probability that you did not graduate?
15.
All right, so 0.15, and I will go back so you can see that. And what's, if you're in the did not graduate,
0.1.
look at the happy branch from 0.6. So did not graduate is 0.5 or 0.15, and then the happy from that branch is 0.6. So we multiply those together. 0.15 times 0.6 is 0.09. So when you said pretty slim, say 9%. It's not too bad. So once you have your tree branch set up, when you want to do this and happy, you simply follow just the two things that it asks. So I don't know if you guys wrote on the back of your packet on Friday, that's fine. If you didn't write on the back of your pack, or you can use the back of your packet if it's empty. If you don't have room for this, get out another piece of paper, because this is probably one of my favorite examples.
Do we get
Huh?
Do we get some points for our notes on the back?
Why?
He's thirsty for some points.
Is that thirsty?
All right, so I will say I had a problem similar to this on the board when AP Stats did tree diagrams. And so you might have seen this or something similar earlier in the year up on the board. But for those of you that don't know, I am probably the worst morning person on the planet.
Yeah.
I absolutely hate waking up in the morning. If I have to have an alarm, I snooze more than I should. And then that gets me into trouble. All right, so here's some information. I want you guys to write this down because if you don't write down the information, the tree doesn't make sense. All right, Mrs. Walker. All right, are you writing?
Yes, ma'am.
Sounds like you need to hit the snooze button.
Huh? All right.
I got a random question, Ms. Walker.
Uh-huh.
How come the snooze button is 9 minutes and not 10? Why is it weird like that?
What do you mean?
Like, why doesn't it just be 10?
I don't know. Every snooze button is different.
Oh, it is?
Mm-hmm.
I didn't know that.
And like on your phone, you can adjust what you want your snooze to be.
I didn't know that. This is not 3 hours.
All right, so I hit the snooze button 85% of the time on school mornings.
Is this factual?
Oh, it's probably higher than that.
Okay, it's out whatever it is.
I hate alarms. I literally cannot stand alarms. Whenever I wake up, I wake up. My mom used to wake me up. I feel like last month, she used to wake me up. I was up at like 7:20 to shower.
It's all right. I just turn the lights on in my kids' rooms and just walk away.
Yeah, that's what she
I let them wake up on their own because they're about like me. All right, so,
My dad wakes me up, I was putting in the mouth. He always says, dude, you're just
all right. Hey, we can't have side conversations. All right, so I'm hitting the snooze 85% of the time on school mornings. All right, you need some more information. All right, so the next sentence. On the days she hits the snooze button, she leaves her house by 7:30 90% of the time. 7:30 is kind of the goal for me because if not, I get stuck behind a bus. And then I have to have to go follow the bus for every single stop until I get to school.
7:30 a.m. guys.
Yes.
Bro.
All right, now I've got one more piece of information. All right, on the days she does not hit the snooze button, she leaves by 7:30 98% of the time. And I will have to say, this year, I don't know if it's just because my kids are older or the fact that school starts a little earlier this year, but there's only been like one day that I was like super, super late. I'm in the middle of teaching. Mm-hmm.
What were you saying?
Okay. I was just saying, I don't know if it's because the school starts earlier this year, or that my kids are just a little bit older, but like I feel like that this year has been the best year, like being on time. And like, which being on time for me means leaving like, I honestly like to be here by 7:30.
Oh, see, I just got like 10 minutes left.
Yeah, I like
to be good about
I
it.
like to be here by 7:30, and so, and if you can see, like I still managed today to even go get a coffee. Like I can get a coffee and be here by 7:30.
Like a
So
week straight, I thought it was cool to wake up at 4 o'clock and then just like watch movies until I was like ready.
That sounds awful.
And then I was like dead tired.
all right. So, do you guys think we have enough information to make a tree?
Oh yeah, for sure.
All right, so what's the first thing that's happening in this? Am I leaving my house or am I hitting the snooze button first? All right, so whenever I make my tree, I have two options in the morning whenever my alarm goes off. What's one of them?
Don't hit the snooze.
All right, snooze or do not snooze. All right. What is the decimal? What was my percent for hitting the snooze button?
85.
85. So just kind of like that example we just had, 85% of the time I hit the snooze, so how often do I not?
0.15.
0.15. 100 minus 85 is 15. All right, so then I give you information about each one of these branches. So then after I hit the snooze button, what are the two scenarios that we're talking about here?
You either leave by something or you don't.
All right, so 7:30 or it's actually after 7:30. I don't want to say not. Let's say after. So I either leave by 7:30 or after 7:30. So when I hit the snooze button, on the days I hit the snooze button, she leaves her house by 7:30, 90% of the time. So what's my decimal for
0.9.
0.9? So 90% I hit or I leave on time. What about this one? If this is 0.9, 0.1, 90 and 10. All right. So now, down here, we have the same two options. I either leave by 7:30 or I leave after 7:30. All right, what is my probability I leave by 7:30 on this one?
0.98.
0.98. Now,
0.02.
there we go.
All of that.
All right, 2% is 0.02. 0.2 is 20%. So remember, any of your percentages, you move the decimal 2 places to the left, and if it's not there, you got to add a 0, so 0.02.
So what are we answering?
All right, I'm going to tell you that in just a second. All right, so the first one, I want you to find the probability
Yeah, I was thinking maybe you guys want to go out and run on Wednesdays. You be alright?
Yeah. Yeah, I'll wait for the recording.
All right. What is the probability that I do not snooze and I leave by 7:30?
Well, 0.15.
You want the answer when we get it?
All right, so tell me what what am I going to multiply here for this?
0.98 times 0.9.
Ooh. Read that again, Lane.
Are you kidding me?
0.15.
What?
0.15 times 0.98.
Yeah, 0.15 is do not snooze. Follow the branch by 7:30, 0.98. All right, 0.15 times 0.98. 147?
That is correct. You're absolutely right, sir. Or it was not like that. It was like a thing.
Are you kidding me?
No, it's a thing. I didn't just plug it, sir.
I know. All right, this one you're doing on your own. Are you guys ready?
Oh, I'm gonna get this one right.
There you are.
All right, what is the probability that I hit the snooze and I leave after 7:30? No, you're doing it on your own.
Oh, I know it.
All right. So on this one, we follow the branch. I heard somebody say it. Not naming any names.
Sorry, guys.
All right, but what do you guys think about 0.85 times 0.1? What do you get when you multiply that?
I don't know, Mike, what do we get?
0.085.
0.085.
Alright, Don would say first looters are.
Hey, you get the game.
Notre Dame football.
All right, are you guys ready for a challenge on this one?
Challenge.
Okay.
Third ball.
All right, I've got one challenge for you here.
Bonus points.
Get it, boys. Get it.
All right, this one only asks you one thing. What is the probability that I leave by 7:30?
Wow. That's kind of difficult.
Why is that kind of difficult?
Yeah.
All right, how many times in the branch do you see leave by 7:30?
1, 2, 2.
All right, I'm going to zoom out just a little bit here. But we actually have 2 times where you see I'm leaving by 7:30.
I took those and multiplied.
I'm leaving by 7:30 here, and I'm leaving by 7:30 here. Hey, side conversations have to stop. I'm going through something that's important. So if I want you to find out when I say leave by 7:30, there's 2 ways to get there. The first way I get there is by, so we snooze and leave by 7:30, or we do not snooze and leave by 7:30. All right, so we talked about this earlier. When we see the word and, what do we do here? Now, what does this mean?
Add.
So what we're going to do is we're going to follow the branch first, snooze and leave by 7:30. What would I multiply here for this branch? Snooze by 7:30. What am I multiplying? 0.85 times 0.9. Then I'm going to add it to the other option. I do not snooze and leave by 7:30, which we did that earlier. What am I going to multiply for do not snooze and leave by 7:30?
5 times 0.9.
Yeah. So if you just have, if I'm only asking you for one thing, leaving by 7:30, that's still coming from 2 different scenarios. So just find the probability of each scenario and then add them together. So the first one is snoozing and leaving by 7:30. So if I take 0.85 times 0.9, that gives me 0.765. I didn't even write that correct. 0.765. Then I'm going to add it to 0.15 times 0.98, and I'm going to cheat because we already did it up here. We got 0.147. Then we simply just add those together. So 0.765 plus 0.147 and that gives us 0.912. So that's saying that 91% of the time, I'm leaving my house by 7:30.
That's pretty good.
It's actually probably better than that this year. I would say when my kids were like 2 and 4, definitely not the case.
91.2% of the time.
91.2% of the time, I'm leaving my house by 7:30.